For 20 million years, almost nothing has died here. Think about that for a moment, a place almost without death. You are looking at the South Pacific Gyre, the largest stretch of open ocean on our planet. Below you, the water is the clearest in the world because it is empty, so devoid of life that sunlight can penetrate over 70 meters deep. It is a biological wasteland larger than the entire United States. The official story is simple. No nutrients from land means no plankton. No plankton means no fish. No fish means no life. A silent blue void. But the official story is wrong. In 2010, the German research vessel Sohn sailed into the heart of this emptiness. Its mission was to drill into the seabed, 4 kilometers straight down. They expected to find sterile clay, a perfect record of cosmic dust and ancient volcanic ash, undisturbed for eons. And here is where our story truly begins. Because what they found changes what it means to be alive. The first core sample came on deck, a long tube of reddish-brown mud. It looked like nothing. It smelled of nothing, just cold, ancient sediment from the bottom of the world. But under the microscope, the science team saw it. Movement, tiny, single-celled organisms, not just a few, thousands, millions of them in every single cubic centimeter of mud. Let that sink in. In the sediment beneath the most lifeless patch of ocean on the planet, they found one of the densest microbial communities ever recorded. The lead scientist, Stephen DeHunt, confirmed the numbers. Up to 100 million active cells per cubic centimeter. That is more concentrated life than you find in the fertile soil of a thriving forest. This discovery was a paradox, a biological impossibility that broke every existing model of marine science. These organisms are trapped in total darkness. They exist under 400 times the atmospheric pressure you feel right now. The temperature is just above freezing. They are starving. The energy flowing down from the sunlit world above is nearly zero. They are, by every measure, the most isolated living things on Earth. The textbooks will tell you this is impossible. Life needs a constant source of energy. It needs food. And yet, here they are, not just surviving, but persisting for millions of years in a state of near-perfect stillness. It raises a profound and unsettling question. If they aren't getting their energy from the sun, what exactly is feeding them? What exactly is feeding them? The answer is not a hidden food chain. It is not some exotic chemical soup rising from the Earth's core. The truth is far stranger. For the most part, nothing is feeding them. You are looking at life in a state of near-perfect suspension, a zombie-like existence that forces us to reconsider the boundary between living and dead. Your body replaces most of its cells every 7 to 10 years. These organisms might not divide for 1,000 years, maybe 10,000. They are, by every scientific measure, the living creatures ever found. The team from the research vessel Sohn calculated their metabolic rate. The results were so low, they were almost undetectable. Think about it this way. If your own metabolism were a roaring bonfire, theirs is a single glowing ember, an ember that might cool for centuries between sparks. So the energy they need is almost zero. But it is not actually zero. Something has to be feeding that microscopic spark. And here's where the story takes a turn from biology to physics. The clue wasn't in the cells themselves. It was in the water trapped between the grains of clay. For 20 million years, a steady, invisible rain of radiation has been falling through the seabed. Natural radioactive elements in the sediment, like uranium and thorium, constantly decay. This process, called radiolysis, is a gentle but relentless bombardment. It splits water molecules apart, and when you split H2O, you get hydrogen. And that hydrogen is the meal. A single atom of hydrogen released once a century. I might be enough to power a single cell for a generation. It is theist lunch in history. A ghost of a meal powering a ghost of an existence. The official science confirmed this. The numbers add up, but here's the part nobody talks about. Radiolysis also creates powerful oxidants, things like hydrogen peroxide. In essence, it creates bleach. The process that feeds them should also be poisoning them, shredding their cellular machinery. So how do they survive a constant bath of poison for millions of years? The answer lies in their almost unimaginable age. They have had time to adapt. A lot of time. In 2020, a different expedition, this one led by Yuki Morono of the Japan Agency for Marine Earth Science and Technology, drilled into this same abyssal plain. They pulled up a core sample of clay that was dated to 101.5 million years old, and from the age of the dinosaurs. Inside, microbes were dormant, trapped in their tomb of mud since the Cretaceous period when T-Rex walked the earth. So the science team did something remarkably simple. They took these ancient starving cells into the lab. They gave them a tiny bit of food, a little warmth, and they woke up. Yes, you heard that correctly. Life, sealed off from the world for over 100 million years, simply resumed its business as if no time had passed. They began to eat, to grow, to multiply. This discovery proves that life can wait. It can pause time itself, waiting for the right conditions to return. And this completely rewrites the rules for where we might find life beyond our own planet. On a cold, seemingly barren world like Mars, life might not be dead. It might just be sleeping. But this revelation forces us to confront a much more difficult question. If an organism can be suspended, unchanging, for 100 million years and then be revived, was it ever truly alive during that time? And what does that do to our very definition of life itself? While you sit and debate the very definition of life, the abyss offers its own, much simpler answer. It does not come from a whisper of radiation. It comes with the force of an avalanche. It begins with a shadow falling from a world of light you cannot see. A 40-ton humpback whale, dead at the surface, begins its final journey. It sinks for 8 days. 8 full days of silent descent through 4 kilometers of crushing black water. The pressure mounts. 100 atmospheres. 200. Then 400. Enough to implode a military submarine. And then, impact. This event has a name. Scientists call it a whale fall. But this sterile academic term does not capture the sheer explosive violence of this moment. It is a sudden mountain of flesh in a world defined by its emptiness. A supernova of calories in a universe of cold. The official reports state that a single whale fall delivers more organic carbon to the seafloor than 2,000 years of marine snow. Think about what that means. 2 millennia of food arriving all at once. The first to arrive are the scavengers. Thousands of pale eel-like hagfish burrow into the flesh, dissolving it from the inside. But they are not the true kings of this feast. That title belongs to the Greenland shark, a creature that can live for 500 years, its eyes infested with luminous parasites, moving with an ancient patience through the darkness. They can strip a whale to the bone in 4 months. But the story doesn't end when the flesh is gone. This is where it gets interesting. The second act begins. An army of opportunists, numbering in the tens of thousands, colonizes the skeleton. not to eat the bone, but to feast on the mud beneath it, now massively enriched by the fallout from the carcass. Then, for years, even decades, the final stage begins. Bacteria deep inside the bone start to break down the lipids, the fats. They release hydrogen sulfide. It is the chemical smell of rotten eggs. And for an entire ecosystem of specialized creatures, it is the smell of life itself. A chemical garden blooms on the skeleton. Mussels, tube worms, ghost white crabs, all powered by chemical energy, not sunlight. This is the official story. A beautiful natural cycle of death creating an oasis of life. But the official story leaves something out, something nobody likes to talk about. The textbooks describe these events as rare but vital. They fail to mention why they are so rare. In the 19th and 20th centuries, industrial whaling fleets killed an estimated 2.9 million great whales. Read that number again, 2.9 million. We did not just hunt these animals. We surgically removed them from the global carbon cycle. Every whale that never lived is a feast that never fell. We effectively starved the largest habitat on Earth, and we never even knew we were doing it. Researchers at the University of Hawaii calculated the brutal math. By removing the whales, we have cut the flow of nutrients to the deep sea by more than 80%. So when you look out across these vast, empty abyssal plains, you are not looking at a pristine, natural desert. You are looking at a crime scene, a silent, sprawling graveyard that we created. And here is the dark irony in all of this. Those zombie microbes from the last chapter, at the ones surviving on radiation for 100 million years, they are the original inhabitants. The whale falls were just a temporary boom, a brief 50 million year long party. And we were the ones who ended it. We turned off the lights and sent everyone home. So now the old guard is all that's left, the patient life that knows how to wait, which forces a question no one is prepared to answer. We thought we were studying a desert, but what if we are actually studying a world in recovery from a mass extinction we caused, and what is stirring now in the silence we created? It is not a creature, not some leviathan rising from the mud. It is a question that burns inside the minds of a very specific group of people, the ones who sail into the heart of the void, looking for echoes of other worlds. Meet Dr. Yuki Morono. In 2020, he led the expedition that retrieved the 101.5 million-year-old microbes, and he is the man who brought them back to life. Think about what that moment must have been like. You are in a sterile lab on board the research vessel JOIDES Resolution. For weeks, all you have seen is the endless blue of the Pacific. In your hands, you hold a piece of mud that last saw the sun when dinosaurs walked the earth. It is cold to the touch. It smells of nothing. It is nothing, a tomb. You place a microscopic sample in a dish. You add a carefully measured drop of nutrients. And then you wait for days, weeks, months. Nothing happens. The silence of the abyss has followed you into your laboratory. Most people would have given up. They would have logged the sample as sterile and moved on. But here is the part they don't tell you in the scientific papers. This work is not about data. It is an act of faith. And Dr. Morono kept the faith. He kept watching. And then, on day 69 of the experiment, one of the cells divided. Then another. Soon the entire colony was awake, a ghost army stirring from a 100 million year slumber. This wasn't just a biological discovery, it was a message sent through deep time. A message that says, life does not need a sun, it does not need a feast. It only needs one thing: patience. And here is where the story leaves our planet entirely. Jupiter's moon, Europa, is covered by a shell of ice perhaps 25 kilometers thick. Beneath it lies a liquid water ocean, twice the volume of all of Earth's oceans combined. It is dark, it is cold, the pressure is immense, and its seafloor is likely bathed in the same kind of life-giving radiation that powers our abyssal microbes. You see the connection now, don't you? The official reports from these deep-sea missions are about microbiology. But the private conversations, the grant proposals sent to NASA, they are about aliens. This is why they do it. The South Pacific Gyre is not just an ocean desert. It is a simulator, a perfect earthbound laboratory for practicing how to search for life on other worlds. You cannot send a multi-billion-dollar drill to another planet without knowing exactly what you are looking for and how to keep it alive. So you practice here, in the deepest, oldest, most life-starved place you can find. You learn how to drill for miles into a sterile seabed without contaminating the sample. You learn how to detect the faintest metabolic whisper of an organism that hasn't eaten in 1,000,000 years. You are not just a scientist. You are an astronaut, training for a voyage to an alien sea. Every core sample is a dress rehearsal. Every revived microbe is proof of concept. But think about the person at the microscope, the immense, crushing weight of this search. Dr. Morono has said that the hardest part is the waiting, the knowing that you might hold the answer to the greatest question ever asked, sealed inside a tube of cold mud. And he admits he sometimes has nightmares about what they might find next. Not nightmares of monsters, but of a life so completely different from our own that looking at it would prove, once and for all, that we are utterly and completely alone. Proves our loneliness. It assumes the first contact will be something you see. But what if it's something you hear? Or rather, what if it's about the inability to hear anything at all? You're looking at what should be the last truly quiet place on Earth, the South Pacific Gyre. For millions of years, the only sounds here were the groan of shifting tectonic plates and the faint whisper of falling marine snow. A profound, unbroken silence. But that silence is gone. The official reports on deep-sea exploration rarely mention acoustics. They detail pressure, temperature, chemistry. No one talks about the noise, because if they did, they would have to admit a terrible truth. We have filled the oceans with our sound. In 1960, the U.S. Navy installed a global network of underwater microphones called SOSUS. Its purpose was to track Soviet submarines. It was top secret, but it recorded something else entirely: the sound of the sea itself. And what those recordings show, decade after decade, is an ocean getting relentlessly louder. Think about this. Since the 1950s, low-frequency noise in the ocean, primarily from commercial shipping, has doubled every single decade. It is a constant planetary hum. For a blue whale, whose songs can cross an entire ocean basin, this isn't just noise. It's a blinding fog. It shrinks their world from the size of a continent to the size of a city. And here is the part that is never discussed. We regulate what we dump into the ocean. We debate overfishing. We photograph the plastic. But sound? It is invisible. It leaves no chemical trace, and so it goes almost completely unregulated. Yes, you heard that right. There are almost no international laws governing noise pollution in the high seas. So you might think, surely the Gyre is safe. It is thousands of kilometers from the nearest shipping lane, the loneliest place on the planet. It must be quiet. But sound travels differently in water, Especially in a deep water layer known as the SOFAR channel, sound can propagate for thousands of kilometers with very little loss of energy. Acoustic monitoring stations, placed to listen for secret nuclear tests, have confirmed the new reality. Even here, in the heart of the void, the drone of a container ship off the coast of Peru is a detectable presence. The thumps of seismic air guns prospecting for oil in the Tasman Sea are audible. We haven't just visited the abyss, we have moved in our noise. Those microbes, sleeping in the mud for 101.5 million years, existed in a world of absolute silence. We shattered that peace in less than a century. It forces a final unsettling thought. We are spending billions to aim our radio telescopes at the stars, listening for the faintest, most distant signal of intelligence. But what is the first signal we are sending from our own world? What is the great broad